Hello, parents and any teachers or students who may be watching. Welcome to Creating Math Ahas. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to focus on some of the subtraction strategies we use in grade 3. In the Intro to Subtraction video, they looked at the meaning of subtraction that we use, removal, take away, those ideas that we knew, very comfortable with, but also comparison subtraction. So I did an overview of that and an overview of some strategies that we use in subtraction. Things like round and adjust, decompose a number, decompose a place, use place value, count up. In this video, we'll focus in on those strategies related to problems that we see in grade 3. Now, you can see some key manipulative materials here, really just two types, right? Two versions of the same material, actually. We have base 10 materials. Now, the base 10 materials, you can see the 100. So we have a 10 by 10, 100 block. Now, I just call it 100. We have a rod of 10. We have unit cubes. As they move up through the grades, they also have a thousands block, a cube, a thousands cube. But I have paper versions I'm also wanting to show here, and I'd like you to see in this video a reason why we might use this version of the manipulative that's just been made out of centimeter grid paper versus this version of the material. So let's look at some of those strategies. As I said, I'll try to move this without spilling it all over everything. So moving those manipulatives makes quite a loud noise, doesn't it? But let's look at some sample problems. Now, the first problem I'd like to look at is a problem like 354. Remove, let's just do 123. Now, if you look at these materials, right? I have 3 hundreds, 5 tens, right? 5 of these and 4 of the ones. And one of the key concepts we have, instead of me working with these materials right now, I'm going to draw the picture. Now, for me, for the hundreds block, that hundreds flat, sometimes you hear it called, I'm just going to draw squares. I've got 5 tens, and I'm going to draw the lines for tens and 4 ones. Now, your children may be drawing different kinds of rectangles for these. They may draw that hundreds flat, like I did, right? So they'll draw squares for the hundreds. And then they'll draw these skinny little rectangles for the tens. And then they'll draw little squares for the ones. There's nothing wrong with that, and you'll see that quite often. What I find, though, is when I work with the children, after a while, these all start to look the same. It's hard to distinguish, especially between the 100 and the ones. So for me, this type of a drawing is more efficient, takes a lot less time than this one. Now, I do want to mention one other thing. This top drawing, I could have drawn it something like this. You see the order in which I place these. Hundreds, I could mix the tens in. As long as I still have 300, 5 tens, and 4 ones, this is still 354. See, I don't have to have them in a certain order for them to maintain their value, because these tools, this will be 100 no matter where I place it on my paper. This will be a 10 no matter where I place it. These will be ones no matter where I place it. I don't want children to think that if I do something like this, I now have 121. That's not what happens here, right? The quantity is represented by the material. So We don't want to force them to have to put it this way. Sometimes it's helpful, but it's not mathematically required when we're using these manipulative materials. What is important for them to understand is that if they're going to remove 123, they're removing 100, 2 of the 10s, and 3 of the 1s. This is using place value. We remove like size units. Now, when your child gets to grade 4, they'll talk about common denominators in fractions. Well, why common denominators? You need the same size unit. You remove 8s from 8s and 4s from 4s and 6 from 6. You get the idea, right? Well, that foundation is built in grade 2 and grade 3 when we look at place value, and we're building the idea that you must remove like size places. It will extend up into decimals in grade 5 because we'll remove tenths from tenths and thousands from thousands, right? Hundreds from hundreds. So if I want to remove 123, it really wouldn't matter which drawing I use, right? I'm going to remove one of the hundreds, doesn't matter which one, but one of them must go. I'm going to have to remove 2 of the 10s, doesn't matter which of them. And I could do this with the physical materials too, and you may see that your children are doing this with the physical materials first. And I'm going to remove 3 1s. The key is I have enough of each size unit that I need to remove 123. So it's easy enough to do, right? I could have done the same idea here. I could have done the same thing here. It really doesn't matter which ones I remove. What matters is in the end, I will still end up with 2 hundreds, 3 10s, and 1 1. And that's occurred in every situation here. There's that consistency. Now, whether I write this horizontally, if I write this vertically, right, I can do how we learned. But I must admit, when I would use that algorithm I was taught in school, I didn't focus on whether these were hundreds, tens, or ones. For me, every place I treated like the ones place: 4 minus 3, 5 minus 2, 3 minus 1. So I wasn't really using place value. I was able to get an answer, but I wasn't thinking about the size of the unit I was removing. So we're using these materials, maybe used with your children, because we really want that idea, that concept of what size unit they're working with. So as I said in the 5 strands video, right, it's conceptual understanding as well as procedural fluency, but procedural fluency includes flexibility and efficiency. And so we're wanting them to be playful with number. We're wanting them to also understand how to use the materials. Now, all well and good when you have enough of each unit, but what if instead of 354 minus 123, we were going to remove 197? Now, these were regrouping type problems. When I learned how to do this, they had to be written vertically. It had to be aligned, right? And we did something when I was in school called borrowing, right? Now we'll call it regrouping. It's instead of thinking of 54 as 5 10s and 4 1s, we might think of it as 4 10s and 14 1s. Now you may find, depending upon where your child is attending school, what their objectives are, you may find that that procedure for learning how to subtract is saved for later on. In some places, it may be saved for grade 4 because it's these other strategies we want them to know. And these other strategies will serve them, I'm going to say, better when they get to mixed numbers and decimals. But you see what you think as we do these. As I mentioned, one strategy is called round and adjust. Okay, so we'll look at the round and adjust strategy. And I'd like you to think about, let's say, and let's just look at 97 cents, right? Or, well, let's look at 97 as 97 cents. Let's say I'm going to go to the store and I'm buying something that costs 97 cents. I have never gone up to the cashier and said, I'm sorry, I only have $1, which I know is 100 cents, but I only have $1. Could I trade you the dollar for 9 dimes and 10 pennies so that I can pay you? See, you never have done that, right? When we've actually used currency, we don't do that. We give them the dollar, we expect them to give us 3 cents. Or in this case, if this is $1.97, we give them $2, get back 3 cents. That's what the round and adjust strategy is. It's that idea. The idea is if I have 354, I'm going to start with the same type of drawing. If I want to remove 197, easy enough. I remove 200 and I adjust by giving back 3. Now you see what we've done is we've taken a problem, a regrouping type problem, and instead of shifting to paper and pencil and having to remember all those steps, I use the round and adjust strategy, which is a mental strategy, right? I can now do this in my head. I remove 200, give back 3, 157, done. So essentially, that's that strategy, right? I think of this as 354, remove 200, but I have to give back 3. I have to adjust because I removed too many. Okay? So round and adjust. Now, another problem or another technique is decompose a place. Now, you may see decompose, and again, some of the objective standards for your school district, decompose a place, it's just break it apart. Right? A fancy name for break things apart, break them apart into 2 groups or multiple groups, but we're going to decompose. And by decompose a place, what I'm meaning is I might want to cut up tens or cut up the hundreds, decompose that place, cut it apart so that I can remove 90 and 7 without doing the trading into all the smaller units. So if we think about 354, and keep in mind, we're wanting to be flexible in how we play with numbers and subtract, and be efficient. And I hope you saw this is very efficient, more efficient than that traditional algorithm we learned, right? In this case, I know I'm going to remove 197. Now I can think of 197 in many different ways, but one way to think of it is as 197 as 100 put together with 97. My other way of thinking of 197 is 100 put together with 90 put together with 7. This is expanded form for 197. Now, you can see how I could do this. I want to remove the 100, and then I'm going to try to break some things up to remove the 97. Now, you remember in the very first slide or beginning, what you saw, I showed you this form of 100, and I showed you this form of 100, this form of 10, and this form of 10. Now you notice, if I have this one and I'm working with this one all the time, I'm seeing all those little squares in there. I see the 100 squares. I see the 10. Here I see the 100 squares, but the beauty of this one is when I flip it over, I see what I've just been drawing, just the square. When I flip this over, I see just that thin rectangle, which is one of the ones I drew earlier. And then we transition. But what this paper also lets me do, and what you may find your children spending a little bit of time doing in grade 3, is doing some decomposing, cutting apart of something like this. I could cut this, and I'm just using a dry erase marker on here, into, 7 and 3. Now, if I want your child to draw the picture, I don't really want them to draw all the squares, and it still may be hard for them to see it, but I could have flipped this over, and I see this as 7 and 3. Okay, so I can decompose a 10. In the same way, I could decompose the 100. I could cut this into 70 and 30. You see, but turn it over, this gives me a little bit of a more efficient drawing where I'm not thinking I have to draw all those squares, 70 and 30. Now, another option for me, and think about that 97 we need to remove. Nothing says, see, I could cut this like this, knowing that I've got 97 and 3 here. Flip it over if I want to see maybe a little bit more of what that looks like. Here's 3, here's 97. I'm decomposing a place, I'm decomposing a unit to help me more efficiently solve problems like this one. So I'm going to look at this version of decomposing first, because that matches this. So if I want to remove 197, see, I could remove any of the hundreds, won't matter which one, and then I can cut this one into 3 and 97, and I remove the 97. What am I left with? 157, right? These 4 and this 3. So I've got 354 minus 197. I remove the 100. I remove that 97. I'm left with 157. Again, this is something I can do mentally. Once I have these images of the hundreds, tens, and ones. Now, let's look at the other version. I've got 354 minus 197. And remember, our other way of thinking of 197 was using expanded form, 100 plus 90 plus 7. I'm going to start with the same picture that we just had. So I've got 354. But this time, I'm going to think of each of these that I need to remove. Now, the 100 to remove is fine, but to remove 90, see, I could cut this into 90 and 10. Let's write that a little easier to see. 90 and 10, right? So I can remove the 90 and then the 7. Remember our version of this? How could I cut? Oh, well, I could cut this into 7 and 3 and remove this. What am I left with? Well, 100, 40, 50, 7. So I'm still left with 157. I've decomposed places, and in this case, I decomposed a 100 and I decomposed a 10. Now, you may find your students doing other versions of this. Once they get the idea, I've seen some children will take 354 minus 197. They use this version for 197 still. They start with the same picture. And they work right to left. Kind of how we did when we learned the algorithm. They'll remove the ones first. They'll remove what they have. Now, this is tricky in some ways, quite smart of them. They remove 4 ones, but they still need to remove 3 more ones, right? To get rid of 7 ones, they still need to remove 3 more. So they will cut the 10 into 7 and 3 again, but this time they're removing this part of it. They'll remove the 10s that they have, right? So now at this point, I still have 4 10s left, but I need to remove 9 10s. So that means I need to cut this into 50 and 50. So see, how has this child thought of this? They had 4 ones, so they thought of 7 as 4 and 3. Part total we'll talk about, right? Part. I had 4, I need 3 more. They think of 90, and there's other variations that will all work very well with this, but because they could remove 40, they thought of 90 as 40 and 50. They remove 40 of them, they need to remove 50 more. And then they'll remove the 100. See, still very efficient. Whether I use this version of removing 197, probably the most efficient for the decompose place. To me, this is the most efficient. Remove 200, give back 3. This is very efficient. Still mental arithmetic. This one still works. They're decomposing a place. The key is they aren't trying to count back 197, right? They're still working with the size of the units. When they remove all of this, what do they have left? They have left the 100, the 50, and the 7. Now, those are removal type approaches to this regrouping type of subtraction problem. I want to show you another version of this. And we're going to look at 354 minus 197. But remember, the other strategy is a counting up strategy. And what you may see is you may see your child using this type of a tool. This is a total part chart. They have the total up here they're thinking of. They have the parts here. Or they have a part total chart. Turn it around. Now, to me, the part total chart, I think of it in terms of addition. I'm combining to get to this total. Here, I think of it more as that decomposing tool. I start with whatever my total is. So in this case, we're starting with 354 as our total, right? I've got this total. I've got one part here, and I'm trying to figure out my other part. I'm going to count up. Now, because this is a small model, I won't use my actual base 10 materials, right? We aren't going to use these, but I'll draw the picture to let you see what I mean. So I start with 197. So if you picture, here's my 100, here's my 90, here's my 7. Now, any teachers who are watching, just right here, do you notice how I'm not just randomly putting dots in or randomly putting the 10s in? What I'm trying to avoid is a situation where they're having to keep recounting everything. I took 90 as 5 and 4. It's a very quick way to know I've got 90. Here I've got 5 and 2. I'm using what they would have learned in grade 1 as a 10-frame representation for 7. Parents, a 10-frame representation, and you'll see this in other videos, but it's one where we have 5 and 5 side by side, usually squares, so it's a 5 by 2 grid. And children very quickly know that when there's 3 empty squares, you have 7. And it doesn't matter where the 3 are, but it's an organizing structure. Similarly, I could have used a domino structure here. But I want them to quickly know I have 197. Now I'm going to count up. See, what I'm doing is I'm using that comparison idea. I'm really using a missing add-in. How many more than 197 is 354? I'm going to count up to get to 354. So I have 197, 198, 199, 200. Okay. Now, I don't want them to keep going by ones, of course, but I'm at 200. What can I now do? 350, 350, right? 51, 52, 53, 54. So 197, 198, 199, 200, 300, 310, 320, 330, 340, 350, 351, 52, 53, 54. Really what we're doing is modeling when you count back change, how that should look to count back change, right? You start with what it cost in a way, and then you count up until you get to the amount of money you were given. That's kind of the concept for counting back change. That's what we did here. What we found was, how many more than 197 is 354? Well, it's 157 more. Now you may see in some of your children's work, and what we're really wanting to move them towards is we want to move away from a blank and towards using an unknown, a letter for an unknown. You may see symbols for unknowns, stars and boxes or whatever. But eventually, when they solve, they'll know, oh, that unknown is 157. Now, you notice how I'm using the word unknown versus variable. In this particular case, the answer is not variable. There's a single answer here. Well, we just didn't know what it was. But this is a counting up strategy, and it's counting up using these hundreds, tens, and ones models, okay? So we can count up. Way to do it. I want to show you another version for counting up. Same problem. Same idea. We're going to think of how many more than 197 is 354. But the model we're going to use in this case is a number line model. Now, your children will be using what's called an open number line. Essentially, I remember in school, many of the number lines we worked with always had 0 and always had all the hash marks, especially in the beginning anyway. Think of this as a segment of that number line. And in that segment of the number line, we're just putting the endpoints, and we're going to try to see how far apart these are. Okay. Now, how can I get from 197? See, those benchmark numbers, really key numbers for us, become important. See, I want to try to get, and I apologize, this won't be to scale, but think about, I could make a jump of 3, and that will get me to 200. I could make a jump of 100. That's going to get me up to 300. Your child may make a jump of 150, right? But we can get that jump of 100. We can get a jump of 50. This is going to get us to 350. And then I can do a jump of 4. And again, I apologize. I know these are way out of scale. But do you see, when I add this up, I'm still at 157. Now, what will happen is some of your children already have a way to get the answer. They know that traditional algorithm that many of us learn. That is their technique. And remember, for those 5 strands, flexibly, efficiently, we need them to be mathematically proficient to be able to use more than one strategy efficiently. So if they know that strategy, what we see them doing, some of your children will kind of have like I call it a chalkboard because I'm old, right? A chalkboard, paper in their head, and they'll picture doing that algorithm in their head, that procedure. And then they'll do one whole jump of 157. If they do that one jump, well, as you know, if they do that jump, that's great. They've shown a picture of the answer, but they've left off key benchmark numbers, key things like hundreds, midpoints for that 100, right? 50s, doing the ones, those jumps. This is efficient. This is showing also the benchmarks. What we don't want is a child to go by ones that whole way, inefficient. You may see some children doing jumps of 10. That's fine, and we move towards more and more efficiency. For your children who know how to get that answer of 157, we don't need to go to larger numbers to challenge them. I can challenge them by saying, okay, I want you to do it in exactly 7 jumps. 1 must be 52. 3 must be the same. Do you see that now has increased the level of difficulty to this? I don't need to go to 4-digit or 5-digit numbers. I can still challenge your child by keeping it here. Now, some of you I know are thinking, yes, but they can get the answer to these other problems. I just want to real quickly show you a couple of ones that they'll see in grade 4. Think about, oh goodness, I'm going to do 5 1/4, remove 3 3/4. This is a regrouping type problem with fractions. And all that work that they learned, that we learn with our 354, and we did something that looked like this. See, this regrouping of the 10s and the regrouping of the 100s across these ones, for many of us, it became moving ones around. That doesn't work here. We have to think in terms of moving 4/4 across. But see, in this particular problem, how could I do this? Well, 5 1/4, remove 3 3/4. Well, I could just remove 4 and give back a 4th. Round and adjust. Remove 4, that's 1 1/4, give back 1 2/4. Done. Round and adjust. I could decompose a whole into 4, so remove some of those 4s. I can use this counting up. I could start with 3 3/4. I know I want to get to 5 1/4. I can do a jump of a 4th to get me to 4. I can do a jump of 1 whole to get me to 5 and another jump of 1/4. You see, this strategy doesn't get me here as easily, but knowing how to do it here and here and here, and doing this round and adjust as we get to more and more efficient problems, decomposing a whole in that case with fractions will get us to what we need for mixed number addition, subtraction, and these strategies will also work for decimal. So I hope this video's helped give you some idea of how these strategies come into play with grade 3 problems. If you found it helpful, please hit the thumbs up, subscribe, hit the bell for notifications so you know when other videos are coming. If you have children in other grade levels, I hope you will look at those grade level specific videos. There'll be more videos coming and we'll look at addition in some separate videos. So I hope to see you there. Thanks for watching.